Hello everybody, welcome to the Henstitute. I'm going to take a look at a few free fall problems just to make sure that everybody's in the right spot. So this first one, number 8, is got a wrecking ball and it's hanging at a certain place, and all of a sudden, so it starts at rest, so it's VI at 0, and then suddenly the cable snaps. So cable's going to snap and it's going to start falling. And it says the time it takes for the ball to fall halfway to the ground is 1.2 seconds. So we don't know exactly what this entire displacement is. I'm going to call it big Y. But we know that when it falls halfway, so when it falls here, I'm going to call this little y. We don't know that. And we don't know what this one is. But we do know the time it takes to do that, so it's 1.2 seconds. What it wants to know is what is the total time it takes to fall from rest all the way to the ground. So in other words, it wants the, I'm going to call it big T. In other words, how much time to go from here all the way to the ground. Now, most people tend to think of this of, oh, if I use this information here in this first little part, then I'll just figure out the time for this, and then we can add it together, 1.2 plus that. And that will work. However, in my opinion, that's a little bit harder to solve this problem. So here's the way I'm going to suggest it. I'm actually going to suggest that we find out what this distance is. So I'm going to use the fact that VI is 0, the time is 1.2, and we know what G is. We've got our good old 9.8 meters per second squared. So using those 3 bits of information, I'm going to suggest we solve for little y. So we're going to use this equation. The fact that y equals VIT minus 1/2 GT squared. Since VI is 0, this part will disappear. So I'm going to solve for little y. It's just going to be minus 1/2, 9.8, and then multiplied by 1.2 squared. And calculate that out. And if I remember correctly, it comes out to be a little over 7 meters. I don't actually have a calculator on me. Let me double check and I'll be right back. Yeah, so it's negative 7.056 meters. The reason I did that is now we do actually know what big Y is. So big Y, since this was half of the distance, is actually double that number. So big Y would be negative 7.056 multiplied by 2. So that's going to be negative, what is that? So that's 6, that'd be a 12, an 11, a 1, and a 14. So this is how many meters total that it's going to actually fall. And then my suggestion is we just use the exact same equation, but this one's a little bit different. Since I want the total time, I'm going to use the fact that big Y equals VI times big T minus 1/2 G times big T squared. And we're going to solve for big T. Now, most people look at this and they go, wait a second, isn't that going to be quadratic, or isn't that going to be ugly? And it could be, except that VI is 0. And this is why I like to do it this way, because we can go back to this VI of 0. Then it's much easier to solve. We know what big Y is. We know what little g is. We just have to solve for big T. And as long as big Y is negative and this negative, we're good to go. Hope that helps.